Hi, my name is Tela Fuente Bermeo and I'm going to explain this problem. The problem says a grapefruit falls from a tree and hits the ground 0.86 seconds later. Part A. How far did the grapefruit drop? So, the grapefruit is in free fall, so it moves by uniformly accelerated motion with constant velocity. So we put then we do this and the answer is 3.6 meters. Part B. What was its speed when it hit the ground? The speed of the grapefruit at time is given by velocity times time is equal to initial velocity plus gravity times time. So we put velocity times 0.86 is equal to gravity times time, that is equal to 9.81 times 0.86. Then the answer is 8.4.
Hi, my name is Julio Carlos Salazar, and I'm going to explain the problem 7 and 9 from the stage 2. The problem says an arrow is shot at an angle of 45 degrees above the horizontal. The arrow hits a tree horizontal distance, that is 220 meters away, at the same height above the ground as it was shot. Use the gravity, it's equals 9.8 for the magnitude of the acceleration due to gravity. The data that gives is 45 degrees, final position 220, and initial position is 0, and the gravity that is 9.8. The formula that used is time, it's equal to raíz cuadrada 2 times initial position, that is 220, minus 220 over minus 9.8, that is 6.7. Then the part B says how long after the arrow was shot should be apple be dropped in order for the arrow to pierce the apple as the arrow hits the tree. You need to use equal this formula, but instead of minus 220, you use 6 meters. So it's time minus 2 times minus 6 over 9.8. That this is minus 1.10. So you need to rest 6.7 minus 1.10, that this is 5.6. And that's all. To the problem 9, says a projectile is launched with initial speed of 200 meters over seconds, and its highest point, its speed is 6 meters. Part A say what was the launch angle of the projectile. The data that give us is You need to choose the formula of initial velocity. No, sorry, 6. It's equal to the initial velocity, that is 12, and cos and cos of the angle. We need to despejar the angle, so it's minus cos minus 1, 6/12, that is equal to 60 degrees, and that's all.
Hi, my name is Rebeca Gasca Cisneros, and I'm going to explain the problems 8 and 10 of stage 2. So first, the problem 8. The problem says a golfer sends the ball over a 3.00 meters high tree that is 14.0 meters away. The initial velocity is 13.5 meters over seconds, and there we can observe the figure, and the question says what is the maximum range of the golf ball, and the answer is 18.6 meters. Okay, and now I'm going to explain the problem number 10. The problem number 10 says a softball is hit over a third baseman's head with some speed at an angle above the horizontal. Immediately after the ball is hit, the third baseman turns around and begins to run at a constant velocity of 7.00 meters over seconds, and he catches the ball in 2.00 seconds later at the same height at which it left at the bat. The third baseman was originally standing in 18.0 meters from the location at which the ball was hit. And there we can observe the image. And the first question says that we need to find the initial velocity with the gravity that is 9.81 meters over seconds to the square for the magnitude of the acceleration due to the gravity. And the velocity is 18.8 meters over seconds. And now the second question is to find the angle in degrees, and the answer is 31.5 degrees.
Okay, we have the problem 4 from the stage 2, and final position equals to initial position plus initial velocity multiplied for time plus 1/2 multiplied for gravity for time squared. Solving this formula is time equal to square root of 2 multiplied minus the starting position divided by the gravity, and y is equal to 52.5. Okay, we have the problem 2 of the stage 2, and is 0 equals 0.90 plus 1/2 and multiplying 8 for 1.79 squared. Then we have minus 0.19 equal to 1/2 multiplied 3 for 1.49 to the square. That gives minus 1.8 equal to 2.2201, and the answer is 0.81.
Okay, so now I'm gonna explain the problem number 3 of this stage 2. An arrow, it says you shoot an arrow into the air. 2 seconds later, the arrow has gone straight upward to a height of 27 meters above its launch point. And for part A, it says what was the arrow initial speed. So for that problem, we have 3 formulas, okay, and the formula that we are going to use is this one. We're going to isolate the initial velocity, and we're going to replace all the numbers of the data, and the result is 23.3. And yeah, that's the initial velocity, 23.3. So now we're going to see the problem number B. Problem B. How long did it take for the arrow to first reach a height of 13.5 above its launch point? So for that, the height is going to be now 13.5. The gravity is going to be minus 9.8, and like already know, the initial velocity is 23.3, and we want to know what's the time. Okay, so now I'm gonna explain the problem number 6. Okay, so it says a relief airplane is delivering a food package to a group of people stranded on a very small island. The airplane fires horizontally with a constant speed of 322 kilometers per hour at an altitude of 725 meters. Assume that the island refers to the point of at a distance from the point at which the packet is released. Okay, so for part A. Okay, so for part A, it says, after a package is dropped from the plane, how long will it take for it to reach the sea level from the time it is dropped? Assume that the package has an initial velocity of 322 kilometers per hour in a horizontal direction. Okay, so I did this sketch. The height is 725. The initial velocity of X is 322. The initial velocity of J is 0, and the gravitational is 9.8, and now we already know that. Okay, so we want the time. So we're going to use this formula. We are gonna replace all the data to the root, to the square root, and the time is 12.16, and that's the answer. Okay, so for part B, it says if the package is to land right